Hello, everyone. Thank you for coming to this talk today about this recommender system. I'm Yifei Wang. I'm currently a senior machine learning engineer at Meta. Today, I'm going to give you an overview of what recommender systems are, how they work, and some of the challenges involved in building them. Recommender systems are everywhere in our today's lives, providing personalized recommendations on social media, e-commerce platforms, and streaming services. These systems aim to simplify our decision making by offering products, services, and contents tailored to our interests and preferences. However, despite their impressive capabilities, recommender systems are not immune to flaws, and there are concerns about their fairness, particularly in their potential to affect marginalized groups. So this talk will dive into the perception of fairness in recommender system, examining the challenges to achieving it, and exploring the strategies to mitigate those challenges. Um, so at very high level, the recommender system automatically alters the post by predicting what you will find the most valuable and relevant. And here's how it works. So first, the system gathers all the potential posts shared by friends, groups you've joined, pages you've followed, etc. And then next, the AI system considered a variety of input signals about each post. These signals might include who created the post and how you previously interacted with them, whether the post is a photo, a video, or a link, or how many of your friends like the post. A light-weighted model is ran to select approximately 500 of the most relevant posts. And the system also applies certain integrity processes to help reduce the distribution of problematic content. From here, the AI system has models that help it to make predictions about the content you will find most relevant and valuable. And finally, the system calculates a relevance score for about 500 posts and put them in the order by the score. The post about the system predicts will provide more values for you are shown higher in your feed. The system also tries to ensure that your feed has a balanced mix of content types. So that means, for example, you wouldn't see multiple video posts in a row, but rather a variety of post types. To help you see the content you enjoy and find interesting, the system has models to help it make predictions about the content you will find most relevant and valuable. These prediction models use underlying input signals to help select content you will most likely to engage with. But what exactly does the AI system predict for? So here are some examples. So for example, there might be a model predict how long you will likely to spend to viewing a post, and how likely you are to scroll past the post rather than engaging with it. The amount of time you will be spending on the platform, etc., etc. Now let's talk about the fairness involved in building recommender system. So under the context of recommender system, fairness refers to the degree to which the recommendations gathered by the system are free from bias and do not favor for discrimination against any particular group of users. Fairness can be evaluated from different perspectives, including individual fairness, group fairness, and algorithm fairness. So we'll take a look one by one. Individual fairness is based on the idea that similar users should receive similar recommendations. This requires that the system do not recommend vastly different items to users with similar preferences, or that it does not recommend the same item to one user while omitting it from another user with similar taste. Group fairness requires that the system's recommendations are distributed fairly among different group of users, regardless of their demographic characteristics such as age, gender, race, or location. For instance, a fair recommender system should not exclusively recommend products to one gender over the other. Last but not the least, algorithm fairness is about the fairness of the underlying algorithm and the data used to make recommendations. This ensures that the recommendations generated by the system do not perpetuate existing biases or discriminations. For example, if a movie recommendation if a movie recommender system disproportionately recommends films by a male director, then the system may be perpetuating a gender bias. Um, Evaluating and achieving fairness in recommender system is a very complicated and ongoing challenge, as there is no one-size-fits-all approach to ensure fairness. However, by understanding and addressing the different perspectives of fairness, we can design and implement recommender systems that are more equitable and unbiased from all users. So in this section, I will cover some of the primary fairness issues that come up when building a recommender system. First is data bias. Achieving fairness in recommender system is a challenging task, as there are numerous challenges that needs to be overcome. One of the most significant obstacles is data bias, which can result in unfair recommendations. The system is trained on historical user data, which may contain biases and stereotypes just from the training data itself. These biases can be reflected in the recommendations generated by the system, and therefore causing some unfair or inequitabilities. For example, if a movie recommender system only recommend films by a specific race or by a specific race, then it may reinforce existing bias and limit diversities in film choices. To address these challenges, data pre-processing techniques can be used to remove or mitigate the effects of biases. For example, oversampling underrepresented groups, reweighting the data, or using techniques such as adversarial debiasing can help balance the data and reduce the impact of biases. Another challenge is diversity. Um, this can this can have implications for underrepresented groups, as their interests and preferences may not be reflected in the recommendation system. To address this challenge, various techniques can be used to promote diversity, such as incorporating diversity metrics in the system. For example, a music recommendation system can use diversity metrics to recommend music that is less popular but aligns with the user's taste. Another challenge is a cold start problem. Um, Recommender system may struggle to provide personalized recommendations to new users who have little to no historical data. This can put those users at a disadvantage compared to users with established profile and more data for the system to work with. This is known as the cold start problem. One way to address this challenge is to use content based recommendations that leverage the features of the items to make recommendations, rather than relying solely on historical user data. For example, a music recommendation system can use the audio feature such as key, tempo, etc. to recommend songs to users who have not established their preferences yet. Although achieving fairness in recommender system is challenging, how should we improve that? One of the most important aspects to achieve fairness is incorporating user feedback. User feedback can be either implicit feedback or explicit feedback. We'll talk about them one by one. Um, it is important for people to have the ability to guide the type of content they see after a recommendation is delivered. The system respond to feedback and refine how they model each person's preferences. For example, if a user watched an entire video or liked a post, and the system also weigh additional signals that show someone is not interested, such as watching a part of the recommended video for just a few seconds before stopping it or clicking away. The system could the system could also further incorporate explicit feedback, which lets people indicate whether they want to see more content like what they just saw. The system takes those signals into account and tailor further recommendations closer to a person's preferences. They can also use other options, such as explicitly hiding or snoozing the post if they choose. Explicit feedback offers direct but more nuanced feedback. For example, there are cases where a user likes a post but then tell the system they want to see less of it, which could mean they've seen enough content like that. With explicit feedback, the data points of, are of a few orders of magnitude less than interaction, which is one of the challenges when using explicit feedback in the modeling. Adding to this challenge, um, explicit feedback is also intermittent and not always present for each person. So this means that the system has to be more efficient with data and build a model that can generalize well to incorporate those explicit feedback. For example, giving the feedback of showing less on a cousin's post about their new convertible might mean show me fewer posts by that person, or show me fewer posts about cars. So an effective system must be able to understand the intent behind the click. To do this, we can use a deep learning model to generate user and post level embeddings. Embeddings are sets of numbers. And those embeddings can help predict the type of content a person wants to see more or less of. A user embedding captures a person's taste, while a content embedding captures the essence of what a post is about. So here is a very high-level overview of the modeling architecture, where we use a neural network architecture to train those embeddings. And the challenge with training those embeddings is that deep learning models typically require a large amount of data to be trained effectively. While we want to be able to cater to users' taste without them having to provide a lot of feedback. To resolve this, we first pre-train the model on other related tasks, such as predicting what user would like to share or like or comment. We then fine-tune the embeddings on explicit feedback data. This allows the model to transfer information learned on the engagement dataset and apply it to the explicit feedback task. Through the process, we are able to take advantage of much larger data volume like engagement, while still optimizing for more precise explicit feedback signals. Another approach to achieve fairness is through AI model management. AI development ecosystems are increasingly complex and challenging to maintain, and we need to develop highly efficient systems to build, serve, and improve their AI models for production. So here are some approaches how we can do that. So first of all, from data governance perspective, an effective a effective AI system management help to ensure the models not only consume the data for a limited and clearly stated purposes, and minimize the necessary data used, and the data is retained only for as long as it's needed. And from security perspective, we can leverage automation to better prevent misuse or accidental loss of model or their data and to provide access to the same. From ownership accountability perspective, we want to ensure that models are actively maintained and documented with a clear owner. And last but not least, from the robustness perspective, we want to promote the AI's best practice to help models run optimally, like frequently retraining, to overcome some of the concept drift or user data drift, stuff like that. So that wraps up my presentation. Thank you very much for listening.